Hi students, in this video we will take a look at the decimal expansion of rational numbers. If we divide 35 by 16, we get a quotient of 2.1875 and this is the decimal expansion of this fraction. When we express a number as a decimal, it is called decimal expansion. There are two kinds of decimal expansions. One is terminating and the other one is non-terminating. Today I am going to discuss you about the terminating decimals and non-terminating repeating decimals. So let me explain you this concept with an example. Consider a rational number 25 over 16. Now let us find the decimal expansion of 25 over 16. So, we will divide the numerator by the denominator. Continue the division till the remainder left is less than the divisor. Since the remainder is not 0,
place a decimal point in the dividend and at the end of the quotient. Then put a 0 on the right of the decimal point of the dividend as well as right of the remainder. Divide again just as whole numbers. Repeat this till either the remainder is 0 or requisite number of decimal places have been obtained. So the decimal form of 25 over 16 is 1.5625. So 25 over 16 is an example of terminating decimal because it has a fixed number of digits after the decimal point. Now, let us consider few more examples. Let's say a number 17 is divided by the number 5. Then the quotient part will be 3.4. Here the decimal expansion terminates after one digit. And here the decimal expansion terminates after 2 digits. The decimal expansion of 1 over 16 terminates after 4 digits. We observe that there are only finite number of digits in the decimal part. These decimals are known as terminating decimals. In terminating decimal expansion, you will find that the prime factorization of denominator has no other factors than 2 and 5. Now consider one more fraction 5 over 3. So let's divide 5 by 3. Following the rules of normal division, we first add a decimal point to turn 2 into 20. Dividing this by 3, we get 6 in the quotient after the decimal point. Since the remainder is not 0, we divide it by 3. This gives us 6 again, but the remainder is still not 0. So we divide again. In this division, the same remainder is repeating itself. And the digit 6 in the quotient is repeated. So the decimal expansion of 5 by 3 is 1.6 with a bar over 6. The bar on 6 in the decimal part indicates it is repeating. Let's take a look at few more examples. 11 over 9, 17 over 6, 35 over 99. And the decimal expansions are given below. In the first example, the first digit repeats. And in the second example, the second digit after the decimal point repeats. Here in this decimal expansion, not just one, but a pair of digits repeats. So all these decimal expansions are non-terminating but repeating. And these decimals are called non-terminating, repeating, or recurring decimals. In non-terminating repeating decimal expansion, you will find that the prime factorization of denominator has other factors than 2 and 5. If you focus on the hurt, you will continue to suffer. If you focus on the lesson, you will continue to grow.